Hello guys, here is the first question of miscellaneous from NBHM 2019. So the question is as follows, where n belongs to natural number is fixed and NCR is defined for 0 to n. We are asked to evaluate a sum which looks like this. C0 square equal to 3 into C1 square plus up to 2n plus 1 into Cn square. So how do we solve this kind of problem? Okay, let the sum be S and here it will be 2n minus 1, and we all know the property that C0 NCR equal to NC n minus R. So if we use that property here, what we get is that here it will be C0 square, right? So we will get 2n plus 1 into C0 square. Next we get 2n minus 1 into C1 square, and up to this term will be 3 Cn minus 1 square, because C1 is same as Cn minus 1, and it will be C0 is same as Cn square. So if we add these two, what we get is that 2s is basically, if we add the coefficient of C0 square, what we get is that 2n plus 2 into C0 square, and next is also 2n plus 2 into C1 square, and we see that coefficients of Cj square is basically 2n plus 2. So what we can do next is that we can take that common and we take the common, what we get that C0 square plus C1 square up to Cn square. So what is our S? S is basically n plus 1 into C0 square, C1 square up to Cn square. And if you look at the sum, you know that how to find it, because it is a problem from class 12. So how do we solve? We look at the coefficient of this. We look at the coefficient of x to the power n from both the side. And what is the expansion of 1 plus x to the power n? It is basically nc0 plus nc1 up to ncn x to the power n, and it is same as and here it will be twice n c twice n x to the power twice n. Now look at the coefficient of x to the power n in left hand side. It is equal to, how do you get x to the power n in the product? Here it is 1, and so you need to look at the coefficient of x to the power n minus 1 in this product. So it is basically nc0 into, in the coefficient of x to the power n minus 1 in this product is nc n minus 1. No, sorry, I am mistaken. The coefficient of x to the power n is here ncn. So the product coefficient of x to the power n is nc0 into ncn. And next, here when it is x, next, so you need to find the coefficient of x to the power n minus 1 here. So it is nc1 into ncn minus 1, and so on up to ncn into nc0, which is basically nc0 square NC1 square up to NCn square as NCr equal to NCn minus r. So coefficient of x to the power n in left hand side is basically same, and coefficient of x to the power n in right hand side is equal to twice n Cn. And since this is an identity, one is an identity, so the coefficient of x to the power n in both sides will be equal. So this equal to this, so our s will be equal to, so this sum is basically equal to twice n Cn, and this is n plus 1 into twice n factorial into n factorial into n factorial by definition of factorial. So this looks like n plus 1 into twice n factorial by n factorial square. So this is our required answer. Now we move to our next question, and our next question is as follows, which is question number 2 of miscellaneous. We are asked to find all positive integers which leave remainders 5, 4, 3 and 2 when divided by 6, 5, 4 and 3 respectively. The question is bit tricky. As you know that you can solve it by Chinese remainder theorem. Here we also can do it directly. So what do we need? We need to solve basically the congruence, system of congruence. X congruent to 5 mod 6, x congruent to 4 mod 5, x congruent to 3 mod 4, x congruent to 2 mod 3. So it is basically x plus 1 equivalent to x plus 1 congruent to 6, which is basically 0 mod 6, and it is equivalent to x plus 1 equivalent congruent to 5, which is basically 0 mod 5, and this is equivalent to x plus 1 congruent to 4, which is equivalent to 0 mod 4, and this is equivalent to x plus 1 congruent to 0 mod 3. And the solution of this system is basically x plus 1 congruent to 0 mod LCM of 6, 5, 4, 3, and it is basically 60. And so x equal to 60k minus 1, where k belongs to z, but here we need to find positive integers, so we take k belongs to natural number. We now move to our next question, which is question number 5.3. We are asked to evaluate, let me see what was the question. We are asked to evaluate the sum n equal to 0 to infinity 5n plus 1 by 2n plus 1 factorial. So how we solve it? It is again a class 12 problem. We first factor out the first term in this factor so that we can divide it, and what we get is that this and this. And this is basically sum of the reciprocals of even factorial to infinity, and this is the reverse one. This is the sum of reciprocals of odd factorials. And how do we solve that? Find the value of this and this. All we know that e to the power x is basically 1 plus x by 1 factorial plus x square by 2 factorial, x cube by 3 factorial, like this. And we first put 1. For x equal to 1 we get, and next we put e equal to minus 1. So we get the coefficient of odd factorials with minus. So if we add these two, what we get, that e plus e inverse basically twice of 1 plus 1 by 2 factorial plus 1 by 4 factorial plus 1 by 6 factorial and so on. So this sum is basically 5 by 2 into half into e plus e inverse, and this is basically, if you subtract it, e minus e inverse, what you get, that 2 into 1 by 1 factorial plus 1 by 3 factorial and 1 plus 4 factorial and so on. So this is basically e minus e inverse by 2. So this is 5 by 4 minus 3 by 4 into e plus 5 by 4 plus 3 by 4 into e inverse. So this is basically half e, and this is 2 e inverse. So that is e by 2 plus 2 by e. This is our required answer. So if you like our videos, please subscribe to our channel and share our videos so that more students can get connected with us, and that will give us enthusiasm to upload more and more videos. Thank you.